How much of it do they actually watch? Yeah.
I haven't watched any of it.
Okay.
I'm not supposed to. I don't know.
Just proof that it happens, I guess.
Yeah.
So level of significance. So I get that is kind of like a counterweight to something. Like it's like you with a level of significance, like and it's like the Greek letter alpha.
Yeah, like a weird fish-like thing.
And then you use it to see if you've made a type 1 or a type 2 error, if it's like right, or like it's kind of like your margin of error. All right. Okay.
Yeah, I think it says can be used to determine if the PV value is small enough to reject the null hypothesis.
And the PV value is like, it's like another check. Or the probability of obtaining a test statistic at least extreme is the one you've calculated. How do you calculate the PV value? The P value?
It was...
The p-value is the same as like the probability, so you do it.
Oh, okay.
It's just like when you type in the z-score and then you do the top.
Just the top number? Oh, okay.
So it's just the probability value, or what is?
Yeah.
So I guess we've been doing that this whole time.
Yeah. Yeah.
Okay. Cool.
Okay, and then if the null hypothesis is rejected, then you just test the alternative hypothesis, like, because you can never prove that one's right. You can only say that it's not wrong yet.
Yeah. Yeah. It says we have sufficient evidence to conclude the alternative hypothesis is true. So even if it's not necessarily like that exact value, I guess it's just true because the other one's false. So.
Did you do the histogram in the little Excel sheet that they gave?
What question was that? 10?
10.
No, I didn't put it in a histogram, no. Did you?
Yeah.
I looked at the one they made in the answer key.
Because the histogram that Excel sheet creates is different than just the normal histogram that I created with the same data in a different Excel sheet, and I didn't know why they were different. But
what does yours look like?
Well, this is what I used the Excel sheet that they gave, but it was like definitely like a different shape. So I'm assuming like because they gave us on the last exam that we're probably always going to have that spreadsheet when we need it. That's true.
Mm-hmm. Yeah, I think I think you'll always get all 3 Excel sheets. If not, you'll get the one that's like applicable to you or whatever. So.
Yeah, I didn't do that histogram.
And then how did you get the descriptive statistics for it?
I went off of the histogram on the answer key.
Okay.
Yeah, I kind of just looked at that one.
Because the Excel sheet spits out the descriptive statistics as well.
Does it?
Yeah. Like the mean, the standard deviation.
I just never feel like downloading stuff to my computer.
Okay, so the null and the alternative hypothesis. So, okay. And then the new formula is not that different.
It looked like the z-score formula.
It's close.
Is it different?
I think the X bar or whatever thing is different. I don't know.
Is it the same? Do you know?
Sorry, 1 second. Let me. So for what is it?
Computing a test statistic. Is
that the z-score formula?
Sure, let me get to it. It's funny how like.
So it looks like the formula we've been using from.
Yeah, because you use that like.
But it's like X bar instead of X. Like it's got the little thing over
so
it.
that just means it's like the sample mean. And so yeah, and you had the X bar in the last one, right? So yeah, it's the same. I think except it's just talking about the sample
minus the average,
which is just like mu.
Was mu what we used in the past? Okay,
Yeah.
so X bar mu,
Definitely like
standard deviation square root of. Yeah, so maybe it's.
Yeah, it's the same.
But it's just a different application of it because we're using it to do what? Trying to prove the problem if it's right or not, or like if we got it right.
Yeah, so you still use it to get the z-score, except instead of like the probability, it's now your p-value. So like that's like the weird thing about statistics is like you'll notice that it's like the same concept, except they'll use it in different things, and so they name them different things. So it's fun.
So, wait, so that becomes our p-value? Like the z-score is a p-value?
No, the z-score is what you plug in to get your.
Okay, so we plug that into the thing, and then I guess the next question on this is like we plugged it into the applet, and then that's what spit out the p-value, which is the thing up on top.
Okay. So that also is the area, right?
Yeah.
Okay.
The area is the probability.
Yeah. And then
which I don't understand why that is. And then because it exceeded, yeah, because if the p-value is low, then the thing is whatever that it's not right. It fails.
Oh yeah. So if you want, my teacher always taught us like if p-value is low, reject HO. So it's like a little rhyme, and that helped me. So.
Because there's HO and HA. And then HO is the null hypothesis. Okay.
HA is the alternate.
Trying to get comfortable with all the Greek lettering too.
Yeah.
I just wish you could. Do you know how to insert that in Word? Is that like a symbol?
Yeah, I do actually. So I do it in like Docs, but we can do it.
Well, Docs is better. I like Docs.
Do you like Docs better? Because I always upload everything to Docs. So if we open that, I can show you.
I wish they wouldn't put it in Word anymore. Or like, because when you upload like the Word assignment,
it's
weird. It's just like
Yeah.
funky because they try to do all that.
So
formatting.
you just go to Insert at the top for Word. For the Docs, and then special characters.
Okay.
And then you can find it there. Like you can search it. So like MU is the mu, and then like sigma, and then what is the? Yeah, I think that's sigma standard deviation. So.
Okay, and so basically, if the p-value is lower than the because if the p-value is lower than alpha, then that puts the null hypothesis into question, or like okay.
It's saying that like we have sufficient evidence that it's not true. So HA is probably what's going to be true, but we can't say like what's true and what's.
How do you determine the level of significance? Is that
It'll
just
be given
something
to you.
Oh, it is? Okay, so we never decide it.
No, like unless you do like your group project, then you'll decide what you want your level of
Okay.
significance to be. But other than that, like they'll always give it to you.
Okay, cool.
And 0 is just theoretically impossible, or no, is not the right number because like you can commit one of the errors or whatever with it.
Yeah, so it's like how confident you are of committing type something error.
So it just never gets to 0.
Yeah.
Okay.
Gosh, man, I really wish. I'm so sorry. I thought you guys were on 8 for some reason, so I didn't do this prep. So.
Oh no, it's okay.
Yeah, we should have invited you over for 8 though. That would have been nice.
Yeah, or
that was quite the process.
6 or 7.
Yeah.
7 was a doozy. Everyone had a. I even was like reading it over, and I was like, these questions don't make any sense.
Okay, so then the reason why they would keep advertising to the age group that they have been is because they failed to reject the null hypothesis. So it's like there's no reason to believe that their demographic is any different than the national average. And that's it, basically, right?
Yeah.
Okay, so yeah, we could probably take the quiz now. Well, what about the one-sided versus the two-sided? It's like it's the equal sign with the X through it that makes it a two-sided.
Because it's.
You don't care which way it goes.
So you would shade like both sides.
And the purpose of coming up with a hypothesis like that is just to have something to test against, or like the reason why we say that we think it's going to be greater than 0 or whatever is because we just want something to test, or
Oh gosh, I'm so sorry. It's been a while since I got over.
Let's reject. HO is true, then it's correct decision. HO is false, type 2 error. Okay, so keeping type 2 and type 1. So type 1 is something is true, but you reject it.
Hold on 1 second. Sorry, I was just trying to figure out that two-sided tail.
Do they have the table, the type 1 and 2 error table?
Yeah.
Yeah, they do.
I just want to relate it to diabetes somehow, so then I always remember it, but I don't know anything about diabetes.
Oh.
So like type 1 and type 2.
I know my teacher like related it to the law. Did they do it in here too?
The law.
I didn't see it.
Okay, let me find that. Where is it on here?
It's about halfway down the page.
This thing?
Yeah. Oh, is it on the prep or is it on the?
I don't know. I just took a picture of it or a screenshot.
You're talking about that one, right?
Yeah, that's the one. Let me just.
Yeah, it's like halfway down the page.
Yeah, because he was talking about like, what's worse to like convict an innocent man or to let a guilty man go, and like in America, we think it's worse to like convict an innocent man, and so HO is true, but we reject. Yeah. So we think that a type 1 error is worse than a type 2 error.
Oh, because the person's not guilty.
Yeah, that's how. Yeah. Okay, thanks.
It made sense when I was reading it, but I can tell I'll probably get them mixed up in the future.
Yeah, because it's like those one things like the central limit theorem, and
Yeah.
they almost should just separate those out into 2 different chapters or whatever, and then like not tell you that you're gonna get confused by it. Because I only got confused because they told me I was gonna get confused. Well, because it's like, which one is these? Yeah.
During like every test, I still like towards the end, I would still write down like the definition of central limit theorem, law of large numbers, because I understand them, but like the wording.
Yeah.
Stupid.
Okay, so type 1 is just like it's true, but then you reject it, and then type 2 is like it's false, but you fail to reject it. So it's like if type 1 is the celestial kingdom, just kidding. And then you well, I guess it's true, but you reject it, so you're not going to the celestial kingdom. I don't know. Just want something to anchor it against.
The kingdom's false, but you accept it. Who knows how? But.
Well, yeah, okay. So the first one is like somebody, a missionary, comes up to them, and they reject the gospel. The other one is like a Jehovah's Witness comes up to them, but they accept it. I guess. So type 1 and type 2. I don't know.
Oh, that's Jehovah's Witness.
Yeah.
Watch, there's gonna be like a question on the test with that.
Yeah. Okay, but if we know that sample mean, so we know it's a z-score. We know that the p-value is that, or is
the probability of area.
Yeah, and then you have to, and then alpha. It's like you have to be greater than alpha, or less than. If you're less than alpha, then you fail to reject the null. If you're greater than alpha, you probably can reject the null, or at least it's in question. And then the greater than sign, or like the equal thing is the equals with the headed.
Yeah.
If it's got a greater than or less than sign, then it's a one-sided thing.
What does it mean if it's two-sided? I guess. What exactly is that showing?
Yeah, that's what he was asking, and that's the one I can't remember. So if it's not equal to, I think that they're just saying that
it can still be accepted, but it can go either way or something.
Yeah, something like that.
Because your guess is either way, but like because if you're using it, at least my thought, like if you're using the greater than sign, it means that you've decided like it's going to go one way. It's going to be greater than 0. So then.
Yeah, you're basically just trying to see like if HO is true or not in that situation, and then you can do further tests to see if it's greater than or less.
But it can be true if it goes either way, or I think I'm just confused.
Yeah,
no, it's okay.
Never mind.
It's probably just because I'm not explaining it right now.
Well, because I think that's what they were saying. Like in the thing is like, yeah, if you do the not equal sign, it's like you're not saying if it's going to be higher or lower. You're saying it could be any.
Okay.
You just think it's going to be different.
You just think it won't be alternative.
Yeah.
Okay.
So we probably know enough to do the quiz now.
I'm down. Yeah. I mean, We always seem to do pretty good, even when we don't understand stuff.
Yeah. Well, yeah, that's the beauty of it, because it's like I just think I do a lot better on tests if you just always have people to bounce
Man,
ideas off.
each other.
I know.
I don't even need notes. Okay, yeah, I started it.
So. And I haven't got any new subscribers to my YouTube channel since I started doing these live broadcasts. It's kind of sad.
He probably lives in some.
Yeah.
What is this stuff?
I don't know if I have a subscriber, but if I did.
You have to post these videos on this.
Yeah, we have to post
Yeah.
on YouTube.
Is that one of the videos where you said something?
No, I was just like, I don't know if she watches.
Oh yeah, that's what it was.
Uh-huh. Looks, I was a teacher. I'm go through 8 videos because there's 8 groups.
And they're an hour long.
Each one's like an hour
I-
long.
Well, but
bet
it's
you
like,
just see
well, it's like, why
videos.
would you want to watch it? You know,
So you think she's
the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. This is true. Remember that the p-value is the probability of obtaining a sample statistic. Okay, so it said it twice.
Which it's the null, isn't it?
Yeah. Suppose that the null
Well, This
hypothesis,
is what you just talked about. 5.
mu equals 10.
This is the one with the cross through the
Yeah,
equal.
because equals would be stating that you think it's this one value, I
It'd
think.
just be that specific one.
Yeah. 21 questions. What?
I know. How do they pull out 20 questions out of this list?
Well, hopefully they're all multiple choice. Which of the following represents an alternative hypothesis for a left-tailed test?
Okay, so I
Oh,
know it's only one of the first 2. It'd be. I always get those stupid signs mixed up.
well, because if it's like this, then it's like it's less
It'd
than.
be less than, so it'd have to be
So
the
left
first. It'd be the first one.
a left-tailed test. If you're thinking about a left-tailed,
Because it's not
that-
like the right skew. Because the right skew is when it's the tail on the right or the left side. No, I always get those skews mixed up.
Oh, that one? So how
can you
they
help
taught
us on the quiz?
Oh yeah, I can help you. So if you guys need help, you can just ask.
Oh,
But
okay.
also with the skew, it helps to like think of it as like your feet. So like your left foot is like a left skewed and your right foot's right skewed because like your toes go up the opposite way. Does that make sense? Yeah. That's how we were taught to remember it. Does that make sense?
So it's like the opposite of what you kind of.
Yeah, it's kind of just opposite of what you think, but it always helps me like
So right skew has the left tail.
Mhm.
Right skew has the left tail.
And you can even-
because
it's
it's
just
like
bigger
this
on the
big
right
fat
side.
thing
Mhm.
on the other side.
Yeah. Does that make sense?
So the
Yeah.
toes thing.
So the toe, so like if you think about like a left skewed graph, it looks like it's right skewed.
Oh,
Like,
just
if you
'cause-
think about it.
Just because like my right foot, like the big toe is on the left side.
Yeah.
Okay.
I don't know if that would help or that confuses you, but
Okay. So which of the following represents the hypothesis for a left?
yeah.
Tailed. So
I think it is.
okay. So the mu is less than 10.
Wait, then.
So saying the average is less than 10. So I mean, well,
Just think about like
So
where
it'd
you
be
would
the first. It'd be
shade.
the first one. Is that saying 10's greater than
the mu is less than 10.
Because the second one, it's saying the mu is greater than 10, and
Oh.
then the last 2 are just not.
Okay, so the average is going to be less than 10. So then if you have the axis that's 0 over here, so if the average is less than 10, that means there's going to be more distributed on this side towards the left side of the thing. So then,
Yeah.
if that's making sense, like I could draw that out, but like, yeah, because if 0's over here and you have like that thing,
Mhm.
then if the average of the numbers is less than 10, then you're going to have more on this side because there's going to be more numbers that actually happen on that side. And if it's greater than 10, it's going to be further out right.
So I think I think you're thinking about a skewed, are you?
Yeah.
Is that different than left-tailed?
Left-tailed is different. It's just basically where you're shading. So like when you're doing a less than graph, like which side of the graph will you shade?
Oh, so it's literally just pretty straightforward.
Yeah.
Okay.
So would you shave the right side or would you shave the left side for a less than?
So
So
okay.
the left side, you'd shade the left side.
Yeah.
So which so it'd just be the first one because it'd be less than 10.
Yep.
Right?
Yeah.
I mean, is that too?
No,
Yeah, I
that's right.
think-
Yeah.
okay.
No, we need to use the Z postulate theorem. Which of the following represents the alternative hypothesis for so it'd be the opposite then.
Yeah.
Remember, determine the outcome of the hypothesis. It's like all these letters. Alpha. Which is the relationship would result in the failing to reject the null
What
hypothesis?
did that fish thing?
It's the
mean?
p-value is less than alpha.
That's the level of significance. So that's it's just like your likelihood of getting a type.
And that's alpha.
Yeah.
Okay.
Yeah.
So
That-
if p-value is less than alpha, then you
Just be the
you
second
reject the null. Or yeah. Oh. Fail to reject. No, because if the p-value is greater than alpha, then you reject alpha. But if the p-value is less than alpha, no, that's the opposite. isn't
Yeah.
it? It's the opposite. So it's
Because if
p-value has to be greater than alpha.
null is low, or if null is low, reject. No, wait.
Yes, that's what you said.
Yeah, but I am saying that wrong now.
Are these open
p-values.
book? We've always wondered that. Are these open book?
Oh yeah.
These
Your
are.
prep quizzes are always going to be open book. It's just your your homework tests or your homework quizzes. I don't think those are. But like this is just supposed to be prep.
Oh,
Does that make sense? So like,
I kind of got it backwards because the homework ones is like their open note,
oh okay.
and I like took that as open everything, but then I was like, crap.
No, I think that's
Okay. Cool. Well,
Interesting.
I guess we can do that.
Okay, so the relationship would result in a failing to reject. It's almost good to like just go back and forth about it before looking at stuff because then it's like it just kind of cements in your head why things are. Because it's like when you have to kind of reach and struggle for the answer, then it's like then you remember it.
Yeah. So if p-value is low, that's what I was trying to say. Reject it.
Okay, so if p-value is greater than alpha, then you fail to reject. Which relationship would result in rejecting the null hypothesis?
That would just be the second one when alpha is greater than p-value.
Yeah. Or p-value is less than alpha.
Yeah.
Yeah. An insurance company is reviewing its current policy rates. It's 1,500. So the 1,500 is mu, right? Which of the following would be appropriate alternative hypothesis to HA? HA, or in other words, yeah, it's the alternative hypothesis. So why isn't the first one HN? Why is it HO?
I have no idea. Sorry.
Because it's like if this one's HA because it's like hypothesis alternative or
I
whatever.
feel like there's some like I don't know Latin meaning to it, but I don't know.
Okay, so the average claim is equal to 1,500. All alternative. So one of the alternative would be like it was not equal.
It said if you want to read the question again, and whenever I read those questions, I always write down the null and the alternative,
Because
so you can remember it.
they're saying they're concerned the true mean is actually
Oh.
higher than this.
Mhm.
Is
Okay.
that the null?
No,
would
That's
it
the
be-
alternative.
Yeah,
Or I mean alternative, sorry.
yeah.
That is the alternative.
That
Yeah.
is so. The alternative would be HA is greater than 1,500.
Okay.
Yeah, when
'Cause in-
HO is equal to 1,500.
Because in here they're saying the average claim amount is, I mean, they give us a list,
Uh-huh.
but it would be
Oh,
it would be the average claim amount is greater than 1,500.
Yeah.
That's,
which number are you guys on?
10.
Oh, okay.
Is it literally just how it says it?
Which of the following would be an appropriate alternative? is the average claim amount is equal. Wait, what did you say it was?
The third one.
Yeah.
Is greater than 15. So those ones are pretty just
Straightforward.
easy.
Yeah.
Okay.
Well, everything's straightforward when you understand how.
That's true.
Okay.
Well, it's kind of hard because I feel like.
Sometimes it just seems too easy.
Yeah,
Yeah.
exactly. So you like want to overcomplicate it and you shouldn't.
Which of the following would be the appropriate null hypothesis? H0. Oh, I guess it's not an O. It's a 0, as opposed to the other one, which is an A. Okay.
When it be equal to 15.
The appropriate null hypothesis. Yeah, the claim amount is equal to 1,500.
Yeah.
I would believe. N equals 40, so they're above 30. Sample mean of X bar equals. So what is it? Okay, so X bar is the sample mean.
Mm-hmm.
So that's the symbol for it. And why is it called X bar? Just because it has X and a little bar over it?
Yeah.
Okay.
Yeah.
But the other one's alpha because it's a Greek letter. Okay.
Yeah. I don't know the.
It's funny how these all get combined. Yeah. The insurance company assumes the distribution of sample means is normal. Is this a good assumption? Yes.
Yeah, because it's over 30. So.
Since the sample size is large, they didn't tell us if the population is normal or not. So, what theorem or law justifies your answer to the previous question?
Law of
Large.
numbers. Law of total probability.
Yeah.
I've never heard of that.
Well, it's not talking about shape. So, and then it's like if you have the large enough sample mean, that's the law of, or then it gets, if you have a large enough population, you have large enough sample size, then it gets closer to the true mean. And that's the law of like. Z, isn't it?
Yeah.
Oh, wait. I think we should go back to that one.
Which one?
13.
Oh, crap.
Central
Okay.
limit theorem. Just kidding.
Yeah.
Is it?
Yeah, it is. Let me
Why?
see what. Let me read it again.
Because it's
Did
saying
it ask if it was for 12? Did it ask if it was normally distributed? Why it was normally
Yes, it says
distributed?
distribution is normal.
Oh, okay.
Yeah, okay.
Yeah, so
That
that's why.
makes sense. I skipped over that part.
oh, the distribution is normal. Okay.
Yeah, and so when it talks about distribution, that's always going to be central.
A test statistic as defined in this lesson. Isn't that the z-score?
Yeah, yeah.
What is z-scores? Well, time to bring out the z-score calculator. The historical means of sales receipts at the grocery store is this standard deviation. Okay, so the z-score is X bar.
X bar minus the mean of 150. Yeah, so 144 minus 150.
Standard deviation. And then it's like the square root of the sample size, square.
It's 36, so just be 6.
How can you be sure? The standard deviation is 40?
Yeah. Is that 40 divided by 6? Is that how you do that, right?
Yeah.
So I noticed sometimes they say it's the top divided by the standard deviation, but then I was like, isn't the standard deviation that divided by square root of the mean?
The square root of the sample size.
Or sample size,
Yeah, and so like the only time that you wouldn't do the square root of n is if they don't give you sample size.
And that's Okay.
like
yeah.
at the beginning. You like won't have any.
That was in
of those.
like lesson 3, and then lesson 5 they introduced. Okay. And so then
Is X bar.
once we
Okay.
get the z-score, we compare that to the level of significance.
So no, with the for 15. So you would just do 15 first, but you wouldn't do the
No.
levels of
That doesn't apply to this one.
no.
Okay.
Like after you plug it in, and then what you get for the top area, that's what, or compared to the level of significance. Well, yeah, but we'll do this one first.
Okay.
So I got a Z.9. Ouch.
I'm gonna open up Excel as well.
What did you get for your Z-score?
Negative 0.9.
Oh, we don't have all.
What's the Z-score? Okay, so we got the Z-score then. If I don't know, you should test it and see what you get.
Yeah. Doesn't let me go to that after page.
Does it?
She said, try it.
Probability is 0. Just kidding. What is the p-value associated with the z-score from the previous question? Well, that's interesting.
Do you
Is it-
only
Is it the probability of the null hypothesis?
So that's the one where you plug into the app.
do you,
Yeah.
do you use both sides, or how?
No, so since at the beginning it said that it was less than,
So you just do that side.
yeah, and you put in
But
the
it-
Z-score.
But it's the null hypothesis that we're testing.
What is the p-value associated?
Uh,
But
what is the p-value associated with the z-score
so
from
you
the
just
previous
need to find the
question?
p-value.
So what is the z-score associated with this test? But this test is either, or is it the alternative
Let's say
hypothesis?
it's-
Because it's like HA is mu is less than 150,
Yeah.
and so we calculated that z-score.
And the Z-score would be the same for both of them. Does that make sense?
So which one are we finding out then for the p-value?
Well, same for
So-
O is equal to 150.
But you're trying to prove if HO is true or not, and so that's why you're testing the alternative hypothesis.
Oh, okay. So that's why
Yeah.
we're going with less than, because we're testing the hypothesis. Okay.
Yeah. And also another way you can tell is just like whatever the Z-score is. So if it's a negative, then you're going to shade this way for the most part.
Mhm.
So you never even test the the p-value for the
No, 'cause
HO,
you're-
because
yeah,
it's always going to be what it says.
Yeah, because you're always trying to like either prove it right or wrong with the
Okay.
alternative. Does that make sense?
Yeah.
Okay.
Okay, so for that it is 0.184.
Yeah. What inferences to make about the whole null hypothesis? Well, our alpha was what? 0.05,
0.05, yeah.
and 0.18 is greater than that. So,
Yeah.
if it's greater than it,
You reject the null.
If
No.
p-value is low,
Correct.
reject them. So is your p-value lower than the level of significance?
no, it's greater than.
Okay, so you would reject it.
You wouldn't?
Fell to reject it.
Yes.
Because that's saying the probability of the z-score being what we said it was. Or what is the p-value telling us then?
So
Like the
you're
probability of.
failing to reject the null, which means like you don't have sufficient evidence to say that the null value isn't true.
Okay, but if it's lower than the p-value,
Yeah,
Or
then
if
you
it's
can
lower
say
than-
that the alternative is probably true.
Okay.
So right now we're saying the null is probably true. And if it was lower than the level of significance, we're saying that the alternative is probably true.
Why is that? I'm just curious because it seems like if it was higher, then it would be you'd reject it because it's a
Yeah,
higher chance to fail. If
it's
I-
something about getting the type. Because it's like your probability of one error.
Oh,
Yeah.
those come in.
And so, gosh, yeah. Do you guys watch the videos with the readings?
Yeah, I do.
Sometimes.
Those help me, and I think they explain it in one of those. But those are like my favorite things because I felt like the readings didn't explain
The
a
readings
lot of
are,
things very well.
yeah, this chapter reading I didn't like at all.
I would like skim the reading and then watch the videos.
Yeah. We have sufficient evidence that the true population mean is 150. That's true, right?
Yeah.
So read all of them.
Because we're stating that we're failing to reject the null, and the null hypothesis is the population mean is 150. And then
I think it says it in the book where it explains the wording. Did you guys read that? Where it says like the wording that should be used if you reject it and if you fail to reject it.
Oh, yeah.
Yeah. So look at that because it says like if you fail to reject it, it should always
can
be there's
go-
insufficient evidence
So it'd be insufficient evidence That-
to
it's less than 150.
yeah. To suggest HA. I think is what it is.
Yeah,
It
so
wouldn't
we
be-
have insufficient evidence that the true population mean is less than 150.
Okay.
There are two types of errors that can be made.
So we
Type one.
accepted that. So
Which one involves rejecting the null hypothesis when the null hypothesis is true? That's type 1. So it's the LDS missionary one.
yeah.
A researcher decided that instead of using level significance of alpha equals 0.05, he will use alpha equals 0.01, which is the following will be true. The probability of a type 1 error will increase. The probability. Because it's a lower alpha. And so with like a lower alpha score, you have more margin of error. No, because the lower your alpha score, the more accurate you are. But obviously, if you get to 0, then like you're more at risk for making one of those errors. But if the alpha score is,
You would be
So the level of significance. Okay, that's what it is. So the level of significance is your likelihood of committing a type 1 error. And so whenever you lower the probability of getting a type 2 error and vice versa. So if you raise the probability of getting a type 1 error, you lower the possibility of getting a type 1. So with this one, if they're lowering the probability of getting a type 1 error, what will happen?
the type 2 error will increase. They didn't want to give any Greek letters to the types of errors.
So, right?
If alpha equals 0.05, compute the error.
that's just on the applet, isn't it?
No, so
No.
so remember level of significance is the probability of committing a type 1.
Also, it is 0.05.
Yeah.
Really?
Tricky.
So
I have one answer. One unanswered question. What? Oh, which hypothesis involves equality? The null
Null,
hypothesis.
yeah.
Right, right.
Cool. Got 100.
Where did my quiz go though?
Well, thanks for letting me join. So sorry that I didn't have this ready before. I feel like I shouldn't.
No, you're still a huge help. Thank you. Did
My quiz go.
you lose it?
I don't know.
Did you save all your answers?
Hopefully, some of them. Attempt 1 in progress. Okay. Continue quiz. There we go. That was weird. I don't know how I got out of the quiz.
Did you keep your answers?
Yeah, I think so. Should make the group quizzes worth more than the test.
That'd
yeah,
be so
that'd
nice.
be nice.